Hey everybody, Mr. Piercy here. What we're going to be looking at in this lesson is a continuation of what we saw previously with our special angle pairs and the relationship of the angles, particularly the measurements of the angles, whenever the lines that we were talking about were parallel when they were cut with a transversal line. So what we saw is in those angle pairs, the relationships was that the corresponding angles, alternate interior and alternate exterior angles, all wound up being congruent to each other, and the same side or consecutive interior angles wound up being supplementary to each other. So here what we're going to be looking at is pretty much the same thing, but from the other perspective. In the previous lesson, we talked about if these lines are parallel, then these angles do this. Well, now we're kind of taking the other approach, and we're going to look at it from the converse's perspective. I don't like, those are hard to see. I want a brighter color here. The converse. So we're flip-flopping the hypothesis and conclusion now. So now we're going to say if the angles are this, then we can say something about the lines, and that's exactly what we're seeing here. Now, here we're talking about a paragraph proof, which we've mentioned it in a previous lesson back when we were talking about a reasoning material. Paragraph proof, two-column proof, flowchart proof. So this was here as part of our vocabulary, so it's just very basic description, proof written in paragraph form. But let's look at the postulate. Now, here, postulate 16. There's really no postulate called number 16. It's just the 16th postulate that's presented in this particular material. The corresponding angle's converse is a much more appropriate name. And essentially what that is saying is that if I have corresponding angles that work out to have the same measurement, then the only way that's possible is if the lines are parallel to each other. So again, there's that converse relationship. Previously we said if the lines are parallel, then the angles are congruent. So now we're turning around and saying if these corresponding angles are congruent, then the lines must be parallel to each other. So same idea, just flip-flopping it around. So here, let's take a look at the example. Find the value of x that makes these two lines parallel to each other. This particular type of example is a very common type of problem that's going to ask you to test your skills of recognizing the relationship of the angles, whether they're congruent to each other or supplementary to each other, and then, of course, setting up and solving an algebra problem. So this is a very, very common type of problem that you'll see in geometry for this type of concept. So if lines imminent are parallel to each other, then the corresponding angles have to be congruent to each other, and that's exactly what we see. So we would say set up the equation to say that the corresponding angles 2x plus 3 must be equal to the 71 degrees. And then you're going to wind up subtracting 3 from both sides, which gives you 2x is equal to 68. And then using the division property, we'll say x has to be 34. So when the value of x is 34, then the corresponding angles would be congruent. That's the value of x that would make line M parallel to line M. So the example that you see at the bottom here that makes lines A and B parallel to each other is pretty much the same concept. What I want you to do is go ahead and pause the video and work it out. Set up the equation, see what you get. And when you're ready, hit play again, see what the answer is. All right. So again, I'm going to just presume that you are doing what I'm asking you to do when I say pause the video and actually work something out. So the corresponding angles that we see here, again, because we want to know what the value of x would be for the lines to be parallel to each other, we will go ahead and set the corresponding angle expressions or values equal to each other, which gives us 5x minus 7 equals 98. Move the 7 over through addition and divide by 5, and we get x to be 21. Now, at this point in the previous lesson, this is where we got into the alternate interior, alternate exterior, and consecutive interior angles. So here we got the same thing. But of course, these are the converses of the theorems that you saw in the previous lesson. But again, instead of saying congruent, 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 now we're looking at it from the perspective of the angles. So if the corresponding angle, or I'm sorry, the alternate interior angles that we see here, if they are congruent to each other, the only way that's possible is if J and K are parallel, and so on. So essentially that's what we're talking about. We're taking the same ideas that we saw in the previous lesson, just turning it around where we put the hypothesis first and the uh, conclusion, or we put the conclusion first and then the hypothesis second. So looking at this here, how can you tell whether the sides of the Nepal flag are parallel to each other? Well, in this case, what we're looking at is a line here and a line here. So the angles that we're looking at, which here and here are congruent to each other, well, those happen to be alternate interior angles that are congruent to each other. So that's what allows me to draw the conclusion that those two lines must be parallel to each other. So go ahead and whenever you're ready, pause the video and try answering checkpoint number 2 and explain why they're parallel or not. So go ahead and pause the video and we're ready, hit play again. All right. So now that you're back, let's check to see how you did with your answer compared to mine. So here I was able to conclude, yes, those two lines have to be parallel to each other. You can show that they're parallel because according to the same side interior angle converse, we would be able to say since the measurements of those two angles are supplementary, meaning they add up to be 180 degrees, that would allow me to say they are congruent, or they are parallel to each other, lines A and B. Here it's asking us to kind of write a paragraph proof. Now this is a little bit challenging for some students because particularly they just see the word proof and they're like, oh, I don't know how to do that. It's scary. Especially when you think of the two-column proof. A lot of students really do struggle with the two-column proof. But to me, a paragraph proof is a much more intuitive way. It just seems like a more natural way for students to be able to show why something is or why something is not correct or the way it is or something. Because this is a natural thing, being able to form an argument and make a conclusion is something that we just have a tendency to do naturally. You practice it in English when you have to make a persuasive argument in a paper of some kind, and that's kind of what we're doing here. So in the figure, we're telling you that line A is parallel to line B and that angle 1 is congruent to angle 3. So can you prove that angle X is parallel to angle, angles aren't parallel. Can you prove that line X is parallel to line Y? All right. So what you would have to do is you'd have to think to yourself, because all of this text, all of this stuff is normally not here. What you have to do is really you're just given this, and you really just have to look at that picture and think your way through it and say, okay, well, let me see. So the text that's provided for you is kind of that inner monologue, that inner thinking to say, okay, well, what is this? What do I know? What did they give me? And based on what they gave me, what can I figure out based on what I know about lines and angles and how they interact with each other? So let's see. I'm going to go ahead and start marking stuff on here. I know this angle and this angle have to be the same because they told me that. So I also know that A is parallel to B. Well, if A is parallel to B, then that makes angle 1 and angle 2 corresponding angles with line X as a transversal line between parallel lines. Well, what we saw in the previous lessons is that if I have parallel lines and corresponding angles, then the corresponding angles wind up having to be congruent to each other. And so that's kind of how I'm starting off my thinking. So angle 1 and angle 2 have to be parallel or congruent to each other. I don't know why I keep wanting to say angles are parallel. But those two angles have to be congruent to each other because lines A and B are parallel. And corresponding angles are parallel to each other. Well, so let me go ahead and put my mark here. If this, that's not what I want. So we'll say this angle is now congruent to angle. So we use the same measurement. We use the same mark to show angle 1 and the 2 are the same. And we use the same mark to show that angle 1 and 3 are the same because they gave us that information. Well, now looking at it, angle 2 and angle 3 those are alternate exterior angles between angle x and line x and y, with line A acting as a transversal line. So if I have alternate exterior angles that are congruent to each other, the only way that's possible is if line x and y are parallel to each other. So you're going through this thought process. You generally are going to just start with some information that is given to you, whether it's just marking on a diagram or like they kind of gave it to us here. This is what we would say is our given information to work with. And then we just say, okay, well, based on what I know, I can conclude this because of this. Here's my statement, here's my reason. But instead of putting it in the form of a two-column proof, it's more of a natural process where you're just explaining it to somebody. So that's how we kind of work our way through a paragraph proof. So it is given that line A and B are parallel to each other. So because of the corresponding angles postulate, angle 1 and angle 2 have to be the same. It's also given that angle 1 is congruent to angle 3, and that means angle 2 and 3 have to be the same, and with the transitive property of congruence. Therefore, the alternate exterior angles have to be, the alternate exterior angles converse is what we ultimately are going to use to show that x and y are parallel to each other. Now, particularly this, guys, understand, this is not a paragraph. Not. Why can't I spell? I'm having a hard time this afternoon. This is not a paragraph. This is essentially 2 bullet points. If somebody came up to you and started speaking to you in that manner, it would sound very robotic and unnatural. So when you're writing a paragraph proof, don't be afraid to, write it out a little bit longer if you need to, because you're using more natural, understandable language. That's okay. So what I want you guys to try and do here is we're using the same stuff, but go ahead and just see, looking at the last example that we just saw, is it possible to show 1 and 3 are congruent, given if angle 1 and 3 are the same, and x is parallel to y, can you show A and B are parallel to each other? So I'm going to go ahead and pause the video, fill in the blanks what you think are going to be, and then come back and see how you did. Okay, so let's see what we got here. Well, looking, and again, I know you have it probably on your paper. It's easier to see where the example is here, but it is given that x, based on the information in how they're setting up problem number 3, it's given to us that x and y are parallel to each other. So we're kind of going backwards what we did a minute ago. Here we're going to have alternate exterior angles, and that means that angle 2 has to be congruent to angle 3. Well, it's also given that 1 and 3 are the same. Then that means that angle 1 and 2 have to be the same by the transitive property of congruence. Therefore, so the last thing we have here, based on the fact that my corresponding angles are congruent, if I'm looking at the angles, then I can say that the lines are parallel to each other. So that's why I call it the converse here. But that's kind of what we're doing as an argument. So the first example that we worked out together, well, that was, we kind of started at point A and worked our way to point B using that reasoning. Well, here it's asking us really to make the same argument, but in reverse order. If I started with the opposite information that we gave you the first time, can we work back to to what we started with originally? That's what we're looking at on that one. Now, to me, this one here is actually really kind of silly, I think. Here, and again, theorem 3.7, this is not a real theorem name. That's just something the textbook writers wrote for that one. This is a proper name for what we're talking about, the transitive property of parallel lines. Well, essentially the transitive property is saying, it's almost like the law of syllogism. We're saying, okay, if angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then we can draw the conclusion that angle 1 must be congruent to angle 3 also. That's what the transitive property is saying. So here, instead of talking about it as far as a measurement of something, we're using a property of parallel lines. Well, if line P is parallel to line Q, and line Q must be parallel to line R, then we can conclude that line P and line R must also be parallel. And that's exactly what we're looking at here. So we have these utility poles. Basically, they're saying that each consecutive utility pole is parallel to the one that came before it. So that means this one and this one have to be parallel because 2 comes after 1. Well, it also means that 3 has to be parallel to 2 because that's the one that comes after that, and so on. So if we go all the way to the end, well, will the last one in the row, T6, will it be parallel to the first one in the row? Absolutely. That's exactly what we're saying. So if T1 is parallel to T2 and T2 is parallel to T3 and so on, then yes, ultimately, what are we? Oh, there, I wrote it there. By the transitive property of parallel lines, and I abbreviated, I didn't write the whole thing. The transitive property of parallel lines, we can conclude that T1 must be parallel to T6. Okay, and to me, that's a very kind of obvious thing. I would argue that that's probably something I can accept without having to be explained. That's yeah, if one thing's parallel to the other and all the time, then yeah, the first one's going to be parallel to the last one. And that's exactly what we're looking at here. I'm not even going to ask you to stop and try this one on your own because it's essentially the same thing. If all of the slats in the window blind are parallel to each other, is the first one parallel to the last one? Well, of course it is. Of course it is. So if you want to go ahead and pause the video, write that down. And when you're ready, hit play again. So moving on. Oh, and that's pretty much it for this one. That's right. I forgot. It's been a little while since I had to look at it, but there we go. So just to recap, here we're using the converses of the theorems that we saw in the last lesson. Where in the last lesson we said, if these lines are parallel, then these angle relationships occur. So now we're turning around and say, if these angle relationships occur, then the lines are parallel. Using that a little bit using that reasoning to create a paragraph proof, and the transitive property of parallel lines, like I said, is kind of a very self-intuitive, self-obvious thing, I guess you would say. That's pretty much it for today's lesson. But again, this one I just want to point out one more time. Keep going. Ooh, turn back. Why won't you turn back? Oh, even my board has had a long day. It's giving me a hard time. This is the one here. This example one, that is the most common type of problem that you'll see for these ideas. Whether it's in the geometry class or outside of a geometry class, whether it's maybe on your PSAT, SAT, ACT, I've seen applications like this well beyond geometry. This is a very common type of thing that you'll be seeing, so that's why I wanted to highlight that one for you guys. But as always, ladies and gentlemen, if you had any thoughts, any questions that that occurred to you as you're watching this stuff, make sure you write them down, share them with me in the comment section of the classroom, email them to me directly. Somehow, some way, let's just get your answers cleared up as best we can. And until next time, ladies and gentlemen, thank you for watching and take care.